चलो see the next question beta. A weightless thread can support tension up to 30 Newton. A particle of mass 0.5 kg is tied to it and is revolved in a circle of radius 2 meter in a vertical plane. Then maximum angular velocity of the stone will be give the options 5 radians per second. That means omega we need to calculate. Under root of 30 radians per second. Under root of 60 radians per second. Fourth one is 10 radians per second. So in order to calculate the value of omega, we need to calculate what beta? Velocity first. Read the question carefully. What exactly is asking? So weightless thread can support the tension up to how much? 30 Newton.
30 Newton, yes.
Okay. A particle of mass 0.5 kg is tied to it and is revolved in the vertical circle. Ante మన దగ్గర it is making a vertical circle like this. That means this is a point of thread and at this position I'm having a stone attached to it, a weightless thread ankundam right now. Okay, so now what you're doing is a weightless thread can support a tension up to how much? 30 Newton.
30
tension
Newton. Yes.
A particle of mass is also given, tied to it and is revolved in the vertical circle. That means now you are giving it a velocity v so that it will be trying to move. Then the maximum angular velocity of the stone and v was the angular velocity anta. We know the relation v is equals to r into omega. That means omega will be equal to v by r.
V by r.
Radius, this r radius is nothing but length of the string only.
Yes, sir, 2 meters.
So when it is at the lowest position, the weight of this one is right now in mg. The tension will be in the upward direction. So T, how do you write this relation beta? Maximum tension will be equal to T max minus of your mg is equals to m into v square divided by L. E minus ikkada vellipote will be getting the tension kada. So this will become how much for me? T max is equals to this will become for me how much? Okay, ikkada cheseskunte ayipotundi kada. Maximum tension how much he is telling in the problem? How much tension he is given in the problem? 30. So this one is a 30 minus mass is how much for me? 0.5. G value is how much for me? 10. That is equals to 0.5 into velocity v square divided by length. Length is given how much for me? Is it given
2, sir.
Meters
2, sir.
Okay, 2 meters. Now tell me this one. Velocity ఎంత వస్తుంది చూడు.
Uh, 25, 50, sir, 50 minus, 50 divided by 0.5. 50 divided by 0.5 will get, 50 divided by 0.5 is equals to v square,
100.
sir. Yes, sir.
100 కదా.
So 10, sir.
10 ఎందుకు? 50 divided by your
v square only.
V square only, na? So V square is 100.
Yes, sir.
Okay, V will be equal to 10.
Yes, sir, that's what I was telling.
Okay, V is equals to 10.
Yes,
now omega omega
we
is
have
equal
V 10 by 2, 5, sir.
10 by 2.
Radians.
So that is equal to 5. So it is 5 radians per second. Which in the?
Yes,
so first
sir.
one. Clear?
Yes, sir.
That is the way how do we do the problems related to the given condition in the vertical circular motion. The chana applications ఉన్నాయి నాన్న. you need to take care of little bit of your problem practice. And so you
Yes,
try
sir.
to
Yes,
complete
once
that all
I'll do
something,
it.
you can easily do the problems related to them better.
Yes,
Okay,
sir.
na?
Oh, yes, sir.
Do one more problem. Yes, sir. Consider the situation. Consider the situation as shown in figure. As shown in figure. Find T minimum divided by T maximum. T minimum divided by T maximum is equals to how much? Situation is something like this. This is your string, and here a bob is been attached to it. And this is the point of your fixing, that is O. Length of this one is nothing but L, and to this one you are given an velocity. Initial velocity is equals to under root of G into L. Now by this, what do you understand better? Will it make a circle?
Sir, no, sir, it won't, sir.
It will never make the circle, kada?
Yes, sir, because it's less than 5 GL.
Yeah, it is less than of your 5G into your L. So that is a basic thing you need to keep in the mind before you approach the problem. And you also know the condition that U is under root of G into your L. And this is U is lesser than under root of your 2G into your L also. That means the ball will oscillate. I told you the condition. The ball will oscillate. The ball will oscillate like a simple pendulum. It will oscillate like a simple pendulum. I told you yesterday these cases.
Yes, sir.
The root of a to GL కంటే కండిషన్ చేసుకుంటే అంటే it will oscillate like a simple pendulum with an angle lesser than ఎంత 90 degrees. అంటే ఇది ఇక్కడికి పోతుంది, మళ్ళీ ఇక్కడికి వస్తుంది, మళ్ళీ ఇక్కడ పోతుంది. It just make the to and
Yes,
fro
sir.
motion like a pendulum clock. ఓకేనా?
Yes, sir.
So now if I'm making a diagram for this one చూడు, ఈ పాయింట్ ఇక్కడ నుంచి ఇది ఇక్కడ ఉండేనా. So this one was a bob. It will go to somewhere at this position అనుకుందాం. Lesser than 90 degrees, somewhere, I don't know. I'm taking that angle is nothing but equal to your theta. And this one is nothing but of your L. So what is happening when you're given it a velocity of your under root of your this one, this will try to make a particle circular motion like this. It is going to this position. So what is the height to which it is being raised? And this is your height to which it is being raised. So he height ఎలా calculate చేస్తాం నీకు ఆల్రెడీ చెప్పాను నేను ఫార్ములా ఇది. H is equals to, how do you calculate the H? H is equals to your L into 1 minus of your cos theta. Every time again you need not write the relations.
Yes,
కదా? So the weight of the body is right now here in this one. This is your mg. Here will be the tension maximum at the lowest position. This will be your T max. When it comes to at this position, the weight of the block will become how much right now for me here? Mg. And the tension here, it is your maximum. So this is your T max. If I resolve this mg into components, so this is also your theta. So this will become for me mg into your cos theta. And here the new velocity will be getting. So here at this position, the velocity will become how much? 0. Why can you tell me 0? Because it is going from mean to extreme. It will stop
It will
here
again
for a
stop.
fraction of a second. Yeah, it will stop
Like
for a fraction of
vertically
a second
upwards
from
throwing.
yeah. Again, it will come back to the mean position. So velocity at the highest position of this part will be equal to how much? 0. Okay, na?
Yes, sir.
So I can calculate the angle, at what angle it is been going. By what relation? Kinematic equation, V square is equals to U square minus of 2G into H. Why minus beta? Because acceleration due to gravity is against the earth.
Again, yes, sir.
It is moving up kada. So G
Yes,
value
sir.
acts in the downward direction, acceleration of the body is an up. That is the reason A I took it is there minus G. So final velocity enter 0. Initial velocity is how much for me? G into your L minus, this is a 2G. H value will be equal to L into 1 minus of your cos
Cos
theta. Ana kada? This
Yes,
U
sir.
value is already given in the problem. How much under root of 2GL? Under root of GL kada. So U square
Yes, sir.
value is G into your L. Isn't it? You just simplify this one. So this will
Sir,
become for
we
me
can
GL.
common it.
Yeah, 2GL into 1 minus of your cos theta.
We can
Okay,
actually remove
so
the
this
bracket
equals
and
to,
we can
yeah,
actually
2GL minus this one will become for me
2GL cos
2GL
theta.
into your cos theta. This will be equal to G into L. అంతేనా?
So if this will go this side, it will become minus.
యా నేను ఇక్కడే మళ్ళీ ఇది చేసేయచ్చు కదా ప్రాబ్లం లేకుండా.
Yes, sir.
ఇక్కడే క్యాన్సిల్ అయిపోతుంది కదా ఈజీగానే. సో ఇక్కడే ఇది క్యాన్సిల్ అయిపోతే దిస్ విల్ బికమ్ ఫర్ మీ హౌ మచ్ 1/2 అంతే కదా. సో 1/2 is equals to 1 minus of your cos theta.
Yes,
That
sir.
means cos theta value is how much beta? I need not write this step now.
Yes, sir.
Cos
1
theta
by
value
2,
is how much
60.
beta? 1/2. That means theta
Theta
is
is
equal
60,
to, that
60
means it is
degrees.
making an angle of 60 degrees with the vertical to oscillate.
Yes,
What is
sir.
asking the problem? He's asking T max and T minimum, isn't it?
Yes, sir.
So he's asking the T max and your T minimum per definition. So T will be maximum at the lowest position and T will be minimum. Sorry, this should be equal to minimum. This will be the minimum at this position. అంతే కదా.
Yes, sir.
Only at the lowest position we are getting maximum. At somewhere at the highest position where the velocity of the particle is zero, the tension should be equal to how much for me? Minimum. అంతే కదా. Vertical circle లో కూడా
Yes, sir.
at highest position the vertical velocity is vertical tension how much it is becoming? Almost like zero. ఓకేనా.
Yes, sir.
ఎందుకంటే ఇక్కడ T max is mg, ఇక్కడ tension is mg cos theta.
Cos theta.
If you
Yes, sir.
multiply anything with your cos theta, this value will become lesser only, na mg kante.
Yes, sir.
So that is the reason here we'll be getting the T minima. So T minima is how much? That one. So I can calculate right now first T max. So T max చెప్పొస్తాడు ఎంత వస్తుంది? So T max is at lowest position కాబట్టి so it is a T max minus of your m into g is equals to your m into your u square divided by your L. అంతేనా?
Yes, sir.
So T max ఎంత వచ్చింది చూడు ఒకసారి. T max is equals to your m into your u square value is how much for me? G into L divided by L plus this minus it will go here. So this will become for me plus m into g. This L gets cancelled. So this value is becoming for me how much? 2 times of your mg. Clear?
Yes, sir.
So we got maximum value is equal to how much for me? 2 times of your mg. Now I need to get the T minimum, this one. How to write the equation? T minimum minus mg cos theta must be equal to centripetal force. That means, so this will be equal to your T minimum minus mg into your cos theta is equals to m into your v square divided by L. Velocity is 0 kabatti this completely will become 0. Antena? So
Yes, sir.
T minimum will be equal to mg into your cos theta. Already we got the value of cos theta. Cos theta value is how much? 1/2. And this will become
Yes,
for me mg by 2. So this is your T minimum, isn't it? So T minimum is mg by 2 and T maximum is equal to how much for me? 2 mg. What is asking the ratio? So it is T minimum divided by your T maximum. T minimum divided by T maximum. T minimum divided by T maximum ఎంత వస్తుంది చూడు. T minimum is your mg divided by 2, isn't it? Into this one is 2 times of your mg. This mg gets cancelled. So this will become for me 1/4. Okay now.
yes, sir.
Okay. So this was the some of the problems related to the vertical circular motion beta. And try to do the problem for the given conditions and try to remember the relations for this one. Okay na. ఒక చిన్న
Yes,
నోట్
sir.
పెట్టుకున్నాను. It is very important. Go and tell me this one. The రాత్రి 12కి లేచి లేపి అడిగినా కూడా చెప్పాలి కండిషన్స్ ఖచ్చితంగా. If u is greater than or equal to under root of your 5g into your L, the particle moves in what? Circular
Circular,
vertical circle.
vertical circle.
Particle moves in vertical circle. Particle moves in your vertical circle. Okay. Number 2, if 0 is lesser than u is lesser than or equal to under root of your 2g into your L, then the particle oscillates like a simple pendulum.
Yes, sir.
Particle oscillates like a simple pendulum, like a simple pendulum in the arc of a semicircle. In the arc of semicircle. Ante kada.
Yes, sir.
And third one is very important again. Third condition ఏమంటే చెప్పొసారి. If under root of your 2g into your L is lesser than
The
u,
top.
when u is lesser than under root of your 5g into your L, then particle will leave the circular path.
Yes, sir.
Particle will leave circular path. Will leave the circular path. Okay. After completing how much part beta? Quarter circle, and before completing the semicircle.
Yes.
If under root of your 2GL is lesser than u and u is lesser than under root of 2GL, the particle will leave the circular path after completing
Quarter.
quarter circle, after completing the quarter circle, and before completing semicircle.
Yes.
Okay, this is very, very
Yes.
important part. Whenever you do the problem, you always need to see these conditions and try to see where is the particle is it. Is it in the completely circle chestunda lekapothe simple pendulum like oscillate avutunda, or else it is moving in the second quadrant and leaving the contact particulation and doing the problem particulation.
Yes.
Okay na? Chestava?
Yes.
Chalo. So, today whatever the assignment I have sent it beta yesterday, you please
I'll
try
do,
to
sir.
complete it, and I'll try to do some more questions also in the next session. So tomorrow, most probably, okay, possible, I will start with your expand. What do you call that one? Center of mass.
Okay, okay, sir.
Okay, na?
Yes, sir.
Take care, beta. Bye.
Thank you, sir. Bye, sir.